In this video, we'll look at derivatives of exponential functions. So up until now, we know how to take the derivative of polynomials and functions that look kind of like polynomials and perhaps involve square roots, so fractions, square roots, things like that. But now we're going to figure out what the derivative of e to the x is. And we actually could do this for any exponential function, but the one that is really important for calculus is the e to the x one, so that's what we'll sort of concentrate on. And you guys are going to really like this because the derivative of e to the x is actually just itself. And it's one of the only functions that has this property. Okay, so the only other function which is its own derivative is really boring. It's 0, because of course the derivative of 0 is 0. So the only two functions that have this property that they are their own derivatives is 0 and e to the x. So this is really kind of neat how clean this is, but of course when you start throwing the product rule, chain rule, quotient rule in, then things get a little bit more dicey. So let's work some examples here. So let's say, for example, we wanted to do the derivative of something like e to the 2x. Well, x here is now just 2x, and so since this the exponent is not a single variable, we have to use the chain rule. So this would be e to the 2x times the derivative of 2x. Okay, so what we've used is the chain rule. And then we need to figure out what's the derivative of 2x, and we already know that, so the whole thing is just 2e to the 2x. So similarly, we could do something like e to the x squared plus x, and that would be, well, again, the derivative of e to some stuff is e to that exact same stuff times the derivative of the stuff. And in this case, we get 2x plus 1 is the derivative of the stuff, and that whole thing is times the e to the x squared plus x. Okay, now one of the common errors that that you tend to make with this e to the x thing is to say the following, and so I'm going to write it in red because it's wrong. So a common error is to say that the derivative of e to the x, and you look at this and you say, oh, it's something to a power, so I should bring the power down and then take one away from the power. And that's not true. Don't do it. Okay. Use this basic rule. Okay, so let's, on the next slide here, we'll do some, an example of product rule and quotient rule mixed in with this. Okay, so let's spice it up just slightly. Let's say that we have something like the derivative of e to the 1 over x. So in order to do this, I'm first going to rewrite it a little bit as the derivative of e to the x to the minus 1, because that's what 1 over x is, and then I can just do the chain rule kind of like we did before. The derivative of e to some stuff is e to the exact same stuff times the derivative of the stuff. And then, so this part's by the chain rule. What's the derivative of x to the minus 1? It's negative x to the minus 2, e to the x to the minus 1. And now we could simplify this, actually I'll put it over here, as negative 1 over x squared times e to the 1 over x. And that's basically it. Okay, so if we have something that's, say, got the product or quotient rule mixed in, let's do one of those real quick. So we could have, for example, something like x e to the x. So here we have a product of two functions, x and e to the x, and so the derivative is the first thing times the derivative of the second plus the second thing times the derivative of the first. What's the derivative of e to the x? Well, it's just e to the x. What's the derivative of x? It's just 1. And so we get x e to the x plus e to the x, or if you want to go ahead and factor this, that's maybe a little bit cleaner of a way. Okay, and so lastly, let's do something that involves the quotient rule. Okay, so let's say, for example, you had something like the derivative of, well, how about we do this one, x over e to the x. So in this case, what does the quotient rule say? It says it's the bottom thing times the, it would help if I wrote it correctly. Bottom thing times the derivative of the top thing minus the top thing times the derivative of the bottom thing, and then the whole thing gets divided by the bottom thing squared. So if we fill all this in, this is 1, so I won't even write it, and then the derivative of the x is itself, and then we have e to the x squared here. Now we could simplify this because both things on top have an e to the x, so this would be e to the x times, 1 minus x all over e to the x squared. And then what I can do is I can cancel this one here with the one of the ones that's down here, because this is like y over y squared. If you simplify, you just have a y in the bottom. And so here we'll have 1 minus x on top and just e to the x on the bottom. So that's pretty much it for now. We'll look at class at some applications of this.